unsquare plus unsquare. First term unsquared, first term unsquared, middle term tells you plus or minus, last term unsquared.
In the homework, from that kind of problem, when it's like, say, 7 that you're dividing by 2.
Yes.
You,
with an odd b.
right.
Yeah. We're going to do what our last example is going to be odd.
Oh.
Yeah.
I was able to get through that.
Yeah. It's ugly with a fraction.
I mean,
Yeah.
a fraction.
Yeah. 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 So the fractions aren't as intimidating as you might think at first. I want to take some of that intimidation out of it. I'm not going to, if anything, it'll be a bonus on the test, but you will see it moving forward in college algebra, so I don't want it to be a surprise. So we'll go through an example like that, and that's why I included it in the homework too.
3.5?
Yeah. No, keep it as fractions. Keep it as lowest term fractions. Yeah. Definitely, because then when you're not only squaring, but then you're unsquaring to do the factoring. Right. So yeah, you can't do that with the decimal, right? Yeah. No, good question. That's a good observation. Yeah. Square root property, release the x plus 3 on the left, and on the right, my job is to simplify this radical before I finish solving for x. Of course, pull out the negative as an I, and then square root of 4 is a perfect square, so it's 2i. Now I can finish solving for x by subtracting 3 on both sides. Any questions on that one or confusion?
Over here, one fraction. You only divide up the x when it's like this by itself. If it's inside the 26 just
Correct. Yeah. Because that's just an x squared and a number. This is a binomial squared and a number. So that's locked up. You can't touch it right now. Of what? No. I mean, it's good. Yeah. It doesn't matter. It's good form to put the minus first, but it's not required in set notation. Yeah. Set notation doesn't require order. I use it a lot of times because that's just my brain likes to look at it better that way, but it's not mathematically required. With this one, you have to do that radical. It's not a perfect square, and it might not be obvious that it has a perfect square factor pair because it's one of those numbers that's not nearly on your multiplication charts. Okay? But you have to check, either making a manual factor list or using the factor list assist in your calculator, because it can be simplified. Okay? So this is real solutions. There's no I, but it's real and irrational. because it still has a radical. Any questions or problems with that? Okay. So let's work through the fraction one. Put it in the proper form. Now my C is my B, which is 7 or negative 7, bless you. Okay. Doesn't matter because once you square it, it's going to be positive regardless. And squaring a fraction, not a big deal. Don't overthink it. You're just squaring by a quotient rule of exponents. You square the top and you square the bottom. So 49 over 4. Don't divide that out to be a decimal. Okay? If it's odd, you've got a fraction. Just square it. So this is ugly looking, but it is totally manageable. Now, on the right-hand side, you're adding two things. Therefore, because at least one's a fraction, you must use common denominators. And I'd love for you to be really fluent at that and go, oh, 1 is 4 over 4, so 4 plus 49 is 53, 53 over 4. But by no means hit a wall on this. Okay? Remember, you can add fractions in your calculator. Just make sure you enter them in parentheses. So 1 plus parenthesis 49 fourths. Gives you a decimal, math, enter, enter. Gives you a lowest term fraction. Okay. So on the left-hand side, same thing with doing the binomial. The left-hand side, really don't overstress on this one. This is a binomial squared, because you created a perfect square trinomial. First term unsquared, middle term tells you the operation, last term unsquared. Just like squaring a fraction means square the top and the bottom, unsquaring the fraction means unsquare the top and the bottom. So this becomes and this is equal, so we found out, to 53 over 4. Now, square root property, x minus, sorry. Now, square root of 53 fourths, but remember our quotient rule of radicals says break up the houses, and you can simplify them each separately. So we have x minus 7 halves is equal to plus or minus square root of 53 over square root of 4. Quotient rule for radicals. Okay. So we have x minus 7 halves is equal to plus or minus square root of 53 cannot be simplified. Square root of 4 can be. So the radical is simplified as much as possible, and now we finish solving for x. So we're going to add 7 halves to both sides. Remember, that stays in front of the plus minus, which means we have a fraction addition problem again. Therefore, we need common denominators. Do we have them? We do. So we can combine those numerators over the common denominator, which is, and they're unlike terms, so we just write 7 plus square root of 53 over the common denominator of 2. It's not that bad, right? I know fractions sometimes make our brains freeze, but so this would be 7 minus square root of 53 over 2, and 7 plus square root of 53 over 2. You should ask yourself, our three numbers here, our two heads and the denominator are 7, 1, and 2. Do they have any common factor? 7, 1, and 2. No. So you're simplified as you can be. Okay.
So you don't have, whenever that 53, you don't have to do that side, like say like 2 times whatever.
Oh, like find a factor pair, like simplify it?
Right.
You should try. Okay. So I looked at 53 and I did the list, do the list in your head, do it on paper, look on your calculator. So yes, just you should try. But if there's not a factor, it's not a perfect square, and if it doesn't have a perfect square factor, then there's nothing you can do. But yes, if it can be simplified, you must simplify it. Yeah. And if it can't, it just stays locked up, the whole thing. Okay. We okay? So the next thing I did is now we're ready to introduce our fourth method, the quadratic formula. Okay. Now, I'm about to show you something that I wrote out for my previous class. Okay. In the interest of time, so we're not too rushed, so we have enough time to practice this method, I'm just going to show you what I wrote out and I'm going to scan it in. Just like I told them, though, I told them to put their pencils down. You don't have to write this down. Okay. I just want you to absorb it. One, it gives you the concept. This is a big, ugly formula, so seeing where it came from can help understand why you use it, okay? And helps you remember it as well, okay? So you don't have to write this down, you don't have to memorize this, but this is what's called an algebraic proof. It's deriving a formula, okay? We're about to use something called the quadratic formula. Well, where did that formula come from? Well, it was derived from something we just did, okay? So I'm going to show you this derivation. I'm going to post it so you can understand it and understand the concept, okay? So, completing the square, and let me not shock your brain with too much overload there. Okay. So, here we've got, and ignore that on the side too. Okay. So, here we've got a quadratic equation. Okay. No numbers involved in this one. Okay. We're just doing pure algebraic manipulation with the letters. What we're going to do is we're going to take that quadratic equation and we are going to complete the square on it. The same steps in the same order we just did. Okay? But we're working only with letters, with no numbers. Because what we want is not just solving a specific equation, but we want a general rule. Okay? So if we have a general rule, that's going to create a formula we can use moving forward. Especially with those that don't have an even b and an a equal 1, we can use this formula instead, which did all the completing the square work first. Okay? So, given a quadratic equation, remember, as I said, the first thing you should do is if there's an a not equal to 1, you have to divide it away. Okay? So the first step was dividing everything by a. Okay? So that left x squared plus b over ax plus c over a, and of course anything 0 divided by anything is still 0. Okay? Now, we need, our next step is to find out what that magic extra number is going to be. Okay? So actually our next step was to move that CA, see that's plus CA? So CA got moved over to the left, to the right-hand side is negative CA. You can see that's in black. Okay? So I did a plus blank and a plus blank, and that CA became negative CA over here. And then plus blank, plus blank. Now I need that magic number. That's still named C. We called it K when we're working with numbers, but this is how the formula is derived. So that is C over A over here, but we need a new number that's going to create a positive perfect square trinomial. Okay? See, same steps in same order. Divide away the A, keep the variable terms on the left, move the constant over to the right, and leave blanks. And now we need to find that relationship, because if this is a perfect square trinomial, then that means it's our linear coefficient divided by 2 and squared. Okay? Well, this is a fraction. Dividing a fraction by 2 is the same thing. Breaking something in half, dividing it by 2 is the same thing as multiplying it times 1/2, right? Divide it by 2, break it in half, those mean the same thing, right?
Yeah.
Okay? So, this is just another way of writing divide by 2. Okay? So I took my linear coefficient and divided it in half, which is the same thing as multiplying by 1/2 is the same thing as dividing by 2. So, I divided it in half and I squared it. So, the fraction multiplication, b over 2a, broke it in half, and then squaring it, b squared over 4a squared. Okay? So that's what I added to both sides. Okay? Now, because I know I'm going to have to add these together, that's where here we went ahead and made common denominators. This was a denominator of a, and that was 4a squared. So to make it common, I had to multiply this one by 4, so I did the same thing on top. And I needed another a, so times a made this a squared and times an a on top. So now they have common denominators. Then, of course, this is now a perfect square trinomial. So x squared unsquared plus b squared 4a squared unsquared, which goes back to b over 2a, binomial squared. And over here, this is negative 4ac plus b squared over the common denominator 4a squared. And then square root both sides. Of course, that releases this as x plus b over 2a. And over here, my quotient rule let me break it up into two houses. Now that negative 4ac plus b squared, I just turned it around so it looks better. Positive b squared minus 4ac. And I also broke up into two houses by my quotient rule, and I can't do anything to simplify that, but this could simplify, right? Square root of 4a squared, those are both perfect squares, so that became b squared, radical b squared minus 4a squared, ac has to stay the same on top, and this became 2a on the bottom. Now I'm ready to solve for x, so I did minus b over 2a on both sides, plus or minus this. Hey, they have common denominators. So I combined them, negative b, I kept the positive 2a on the bottom, so it's a common denominator, negative b plus or minus square root of b squared minus 4ac. Okay. This is the quadratic formula. And all the quadratic formula was squaring, completing the square on your basic quadratic form equation. Right. So when you've got basic numbers of even b and an a equal 1, you just complete the square on the numbers. That was real straightforward what we just did. When you got a nice pretty one like that with an even b and a equal 1. Okay. But if you've got one with sort of bigger, uglier numbers, this is often the best choice because the quadratic formula means all that work of completing the square has been done for you. You just go straight to the solution. That's the thing about this formula. What do you see on the left? An x. Anything else? Nope. What do you see on the right? Do you see any x's? No, just a's, b's, and c's. A's, b's, and c's are numbers. This is the quadratic formula means you are solved for x. You're done. This is the solution. The quadratic formula is the solution. X equals, all you have to do is plug in your a, b, and c, crunch the numbers, as I call it. Okay. There's no x's over here. Just crunch, simplify the numbers. You're already solved. You just have to simplify your numbers. Okay. Make sense? That's what this formula is about. It's about doing the work of completing the square before on the letters, so all you have to do is crunch the numbers. You already go to the solution form. Now, this is a really important thing right here. You look at this formula, I go, you have to memorize this. I'm not going to put this on the test. You have to memorize it. And we're like, brain freeze. I often find it easier, and it also is going to help you understand more about the problem because when we talk about the discriminant. It helps you break the formula into two parts, and it becomes much more natural to memorize automatically. This radicand right here, the radicand b squared minus 4ac, is called the discriminant. Okay? And I mark it as big D is the discriminant. Okay? Doesn't include the radical sign, it's just the radicand b squared minus 4ac is known as the discriminant. That's the word that means it helps you discriminate, not discriminate in a bad way, discriminate in a good way because that means you can tell the difference between things. It helps you discriminate what type of solutions you're going to get. It's going to tell you whether you're going to get one or two solutions, whether they're going to be real or non-real, or whether they're going to be rational or irrational, just by looking at this number. Okay. So the first thing you want to do in using this formula is take your a, b, and c and do b squared minus 4ac. Just plug it right in the calculator, and that's going to give you a number. Okay? And that number we're going to call big D. And big D, whatever big D is, whether it's positive or negative, whether it's if it's positive, is it a perfect square or not? Or is it equal to 0, or is it negative? Those four things that can happen with the D are going to tell you what kind of solutions you have. And then all you do is plug that D instead here, there'll be negative b plus or minus square root of D over 2a. Much easier to memorize that, right? Kind of think of it in two parts. Like I said, I'll plug that in, but let's do our study page now. So, the summary, study page, and examples for our fourth method called the quadratic. That's off. Quadratic formula. Oh, I meant to write solve with the quadratic formula. Okay. And this is 12.2. Okay. So, when do we use this? Well, we can use it for any quadratic. Any quadratic equation can be solved using the quadratic formula. No restrictions. Now, it's absolutely silly. It's not hard to use, but most of the work is all the work is in the simplifying. So if you use something that's really easy to factor, or a equal 1, or really simple to just do square root property, or even complete the square because b is even and a is 1, then this is really overkill. You can use it. It works for anything, but it's kind of a silly choice if you've got other kind of less messy methods. Okay? But in the end, if you're stuck, doesn't matter what it is, if it's a quadratic equation, this will work. Okay? So you can use it to solve any quadratic equation. Of course, a quadratic equation algebraically is ax squared plus bx plus c equals 0. Okay. Anyone. Okay. However, the best time to use it, the best choice, aside from on the test, I'm going to say use it. Okay. Same with completing the square. I'll say use completing the square. You might say, oh, I'll just plug that into the quadratic formula. You won't get credit for it. Okay. The directions on this exam are going to be very specific and important. You get credit for using not just for the final answer, you get credit for this using the correct method. I want to see that you can use all 4 methods. Okay? So, but moving forward, when you're just deciding, oh, which method shall I use, then you want to be able to make good and efficient choices. Okay? So the best choice is if it's not easily factorable. Oftentimes something is factorable, but it's not easy. It's like an a not equal to 1 trinomial with really big numbers. And you can factor it, but sometimes in those cases, the quadratic formula is actually easier than factoring it. So if it's not easily factorable, and if a is not equal to 1 and b is odd. Okay. So if it's easily factorable, factor it. If a is 1 and b is even, just complete the square. And of course, if it only has a quadratic and a constant, you have to use the square root property. So you can use it for anything, but it's best if you got something that's going to be messy otherwise. So your setup is ax squared plus bx plus c equals 0. In other words, standard form. This is all about crunching those numbers, a, b, and c. If you do not have it in standard form, you will not have the correct a, b, and c. This is all about keeping your negatives and positives straight, and you do not know what your a, b, and c are with their correct signs until it's in standard form. So if you don't do this first, the correct setup, you will get it wrong. So your steps are, first, put in standard form. And you'll see, like, I think one of these on homework, and I'm going to give one of these as an example, is to kill any fractions. If there are any fractions, kill them. By multiplying every term by the LCD over 1. Okay. You can use fractions for your a, b, and c, but do you really want to plug fractions into this? No. Because it's an equation, you can legally just kill them all, be fair at every term, and then your a, b, and c are nice, clean integers. Okay. All right, so it's nice and cleaned up in standard form, no fractions, and so make a note. Okay. I do this because I lose track if I don't. I strongly suggest you write underneath your standard form quadratic equation, you write a, b, and c. Okay, pull them out of the equation. Because if you leave them in the equation, at least the way my brain works, you see what happens with you in homework, is I sometimes then get the sign wrong. I want to see just a clean number, either positive or negative. So I'm real clear on what my a, b, and c are with the positives or negatives. Okay. Next, so you note your a, b, and c, and then you find your discriminant, okay, which is d. Okay. And d is found, d is equal to b squared minus 4ac. Remember, it doesn't include the radical, it is the radicand. Now, when you find that discriminant, you want to know what that discriminant means. In fact, that's going to be some of the homework questions. It's going to ask you about the nature of the solutions. The discriminant, what the discriminant is going to tell you whether you have 1 or 2 solutions, whether they're real, and if they're real, whether they're rational or irrational, or if they're non-real. Okay? So that number is going to be a single number, and these are the 4 things that could happen. D is positive. D greater than 0. D is positive, and it's a perfect square. Okay. Now remember, D, the discriminant, is the radicand. And what happens to the radical sign if you have a perfect square as the radicand? Do you have any more radical sign? Let's say D was 49. Well, you plug in the formula, that's square root of 49. What does that give you? 7. Do you have any more radical sign? No. So if D is positive and it's a perfect square, radical gone. Huh? In that case, you have, because it was positive, because it's positive, that means that you have real solutions. Even more specific. See how this is a plus minus? That means you've got some number plus or minus this radical, so over a denominator. So it's going to be one solution will be with minus and one solution will be with plus. 2 solutions. Okay? So if you have a positive D that is a perfect square, you have 2 solutions. And they're going to be real solutions. Okay? Because it's positive, not negative radicand. It's positive radicand. And because it's a perfect square, they're also going to be rational solutions. Meaning no more radical. Radical goes away. Remember, from our numbers from the first day, with working with complex numbers, but that's, we looked at, had that handout that had, real numbers, and they can either be rational or irrational. Okay? Non-perfect squares or leftover radicals are always irrational. Okay? So, perfect square means 2 real, perfect square and positive, 2 real rational solutions. Okay? Now, if you have a positive D, but it's not a perfect square, you're still going to have 2 solutions and they're still going to be real because it's a positive D. And you've got a plus, negative, positive D, so that's 2 real solutions, but you'll still have a leftover radical sign because if it's not a perfect square, you'll have leftover bits. So these will be 2 real irrational solutions. Okay. Now, if D is equal to 0, what is the square root of 0? 0, right. So, is there any difference between plus 0 and minus 0? Yeah. So that means, how many solutions will you have? Yeah, just one. And the solution will be negative b over 2a. Yeah. Just one solution because plus 0 and minus 0 doesn't change anything. So instead of that plus minus, it's still real because 0 is a real number and it's a positive, well, it's not positive or negative, so it's not non-real. Okay? But you will have only one solution because if it's plus or minus 0, it doesn't change anything. And it will be real. Okay? One real solution. And because there's no radical sign left, then it's also rational. Now, one real solution, that means 1x. What does that mean the parabola would look like?
A straight line.
Now, parabola is always a curve, but what's the x? How many x-intercepts will you have?
Just one. So it'd be at the vertex would be at the x-intercept.
At the x-axis, right. The vertex and the x-intercept would be the same. It would hit, yeah. Okay. And D, less than 0, that means D is negative. Your radicand is negative, which means your solutions are